In this figure, we have a circle, and inside this circle, we have a sector ABC that is part of another circle. The radius of this sector is 12 units, so AB is 12 units and CB is also 12 units. You can think of a sector as a slice of a circle. The angle ABC measures 60 degrees and we need to find the area of the green region. We will start this problem by connecting the points A and C. Now we have a triangle formed, and this triangle is equilateral. And this is because if the sides AB and CB are equal, then their opposite angles are also equal. And if this angle is 60 degrees, then each of these angles will also be 60 degrees. Now, to find the area of the green region, we will need to find the area of the circle. Then from this area, we will subtract the area of the sector ABC and the areas of these two segments. Now, to find the area of the sector ABC, we will use the following formula. So here we have a sector with an angle theta and the radius r. Then the area equals theta over 360 degrees multiplied by pi r squared. So if the area of a circle is pi r squared, then the area of a sector is a fraction of the area of a circle. To find the area of this sector, we will replace theta with 60 degrees and r with 12. So A equals 60 degrees over 360 degrees multiplied by pi times 12 squared. If we reduce this fraction, we will get 1 over 6, and 12 squared is 144. So we will have 1 over 6 multiplied by pi and multiplied by 144. Then because 144 divided by 6 is 24, the area will be 24 pi. In the next step, we will find the areas of these two segments. A segment is a figure that is bounded by a chord and its corresponding arc. Now here to the left, I just created another example of a segment, and again, this is a figure that is bounded by a chord and the corresponding arc. To find the area of one of these segments, we will start by connecting the center of the circle with the points A, C, and B. Now let the center be represented by the letter O, and on the arc AB, let's have another point D. And now let's take a look at the sector OBDA. To find the area of the segment ABD, first we need to find the area of the sector OBDA and subtract the area of the triangle ABO. To find the area of this sector, first we need to find the radius of this circle. For this, from the center of the circle, we will draw a perpendicular to AB. And let this point of intersection be point E. Then now we have a right triangle formed OEB. The side EB is 6 units because this is half of 12 units, and the angle B is 30 degrees because this is half of 60 degrees. And this is because in the equilateral triangle ABC, the angle bisectors meet at the center of the circumscribed circle. Now, to find the radius of the circle, we will use the cosine function. We will write that cosine of 30 degrees equals the adjacent side 6 divided by hypotenuse r. So again, cosine of 30 degrees equals 6 over r. Then r equals 6 divided by cosine of 30 degrees. Cosine of 30 degrees is square root of 3 over 2, so we will have 6 divided by square root of 3 over 2. Now we will convert this division into multiplication by flipping the second fraction. Then 6 times 2 is 12, and now we have 12 over square root of 3. To rationalize the denominator, we can multiply the numerator and the denominator by another square root of 3. Then in the numerator we will have 12 square root of 3, and in the denominator square root of 3 times another square root of 3 is 3. Then 12 divided by 3 is 4, and the radius is 4 square root of 3. Now, once we know the radius, we can find the area of the sector OBDA. The angle of this sector is 120 degrees because this is 1/3 of 360. Then area equals 120 degrees over 360 degrees multiplied by pi times radius squared, and the radius is 4 square root of 3. Then 120 over 360 is 1/3 multiplied by pi, and 4 squared is 16, and square root of 3 squared is 3. Then if we cancel 3 and 3, the area will be 16 pi. In the next step, we will find the area of the triangle ABO. To find the area, first we will have to find the height EO, and we will find it using the triangle OEB and the Pythagorean theorem. According to the Pythagorean theorem, side EO squared plus side EB squared equals the hypotenuse squared. So again, EO squared plus 6 squared equals 4 square root of 3 squared. Then EO squared plus 36 equals 16 times 3. And EO squared equals 48 minus 36. Then 48 minus 36 is 12, and EO will be equal to the square root of 12. Then if we write 12 as a product of 4 and 3, then square root of 4 is 2, then EO will be 2 square root of 3. And now let's find the area of the triangle ABO. The formula for the area of a triangle is base times height divided by 2. The base of the triangle is 12, and the height is 2 square root of 3. All this will be divided by 2. Then the area of this triangle is 12 square root of 3. And now, once we have the area of the sector OBDA and the area of the triangle ABO, we can find the area of the segment by subtracting the area of the triangle from the area of the sector. So again, the area of the segment is equal to the area of the sector, which is 16 pi, minus the area of the triangle, which is 12 square root of 3. So this is the area of this segment. Then the area of this segment is the same because these two segments are equal. Now in the next step, we will find the area of the entire circle. The formula for the area of the circle is pi r squared, and the radius is 4 square root of 3. Then A equals pi times 16 times 3, which makes 48 pi. Now, once we know the area of the entire circle and the areas of these two segments and the area of the sector ABC, then we can find the area of the green region by subtracting these three areas from the area of the circle. So the area of the green region equals the area of the circle, which is 48 pi, minus the area of the sector ABC, which is 24 pi, minus double the area of the segment, which is 16 pi minus 12 square root of 3. So again, this 2 is here because we have two equal segments. Now 48 minus 24 is 24 pi minus, and now we will distribute 2. 2 times 16 pi is minus 32 pi, and negative 2 times negative 12 square root of 3 will be plus 24 square root of 3. Here we can also combine 24 minus 32, which is negative 8 pi, plus 24 square root of 3. And if we use a calculator, we will have approximately 16.44 square units. So here we have the area of the green region, and now the problem is completed. Please subscribe to my channel, leave a comment, and thank you for watching.